Hi everyone, so welcome back to this channel. And today I'm uh, going to record this video after a very long time since I was busy working on the website development, uh, which I'm going to announce very soon that we will be launching our website uh, where you can get all the basic or advanced blogs with respect to the channel which I'm uploading right now on my YouTube. So um, that's all the brief I want to give you here before actually starting this video. So in this video, basically we are going to discuss reading text files in IFS in AS400. So basically, in my previous video, which I uploaded uh, 9 days ago, where I discussed about creating or writing a text file in IFS AS400. So that's easy, where we actually know that how much bytes of data we need to write on the IFS file. But um, when it comes for reading a text file in AS400 in IFS, uh, it's being tricky sometime because we don't know how much data or how many bytes we are going to read, and after how many bytes the file ends. So even we also need to identify the next line when it comes the next line, basically the CRLF, the carriage return, and the line feed characters which are inserted within the text, which basically denotes that when the next line is going to start. So we need to even differentiate the lines as well. So here in this video we'll see how we will be reading a text file in IFS, um, so that we'll be extracting the every line from the text file. So let's uh, see the demo. So here I already have written one program. Let me show you. So first thing is these are the basic things, which are basically the error number API or the error message API with respect to that error number. I'm using these two API everywhere because we are going to handle the errors. We are performing the error handling. So in case any error occurs in any of the IFS API or the C API, we will log that into the job log. So let's see the next API, that is the read API, which is basically used here. So read API, you can get all these information about the read, close, open, error APIs from my channel. I have created separate videos on all these APIs on my channel, which you can refer in the IFS programming playlist. You will get the detailed information of these APIs from there. So read API will basically accept the uh, file descriptor, okay, and it will return me the buffer which I read from the file. So it also denotes the number of bytes which have been read. So basically this is something which I provide to the API, that how many bytes to be read and how many bytes to be read, and I'm going to provide the address of that buffer. So basically let's say I'm going to read 10 bytes of data, so I'll pass the address of that variable having the 10 characters defined with that, and it denotes the size of that variable. That's the thing. So we'll receive, basically we will receive the data into this buffer once we perform the read API, and here in read API it will return me the actual number of bytes which we read. Let's say suppose I asked for 10 characters or 10 bytes, but it returns me, let's say, 8, because there are only 8 bytes left. So that's okay, that's fine to me. No issues with that. Then we have a close API which will close the files which are opened on the IFS using the file descriptor which is assigned to that API. So file descriptor is basically returned from this open API when we open this the file in the IFS. So we'll pass the IFS path, that is the file path, the open flags, the mode flags, code page flags, all these things we pass. You can get the information from the separate videos which I already uploaded on the channel. So these are the flags associated with the O flag parameter in the open, where I pass whether I have to read the file or write the file, read or write both, or create the file, all these things. And this is basically used when I opt for creating a file. If it does not exist, then I can provide the authorities to the file like this. We have some variables like fs path, O flag mode code page which is passed to the open API, then the file descriptor returned from the open API. This is the data which I'm going to read in. That's 10 characters, so I'll be reading 10 characters at a time from the IFS file. This will be the return from the read, and this is return from close. And these are the pointers which are going to return from the error underscore error APIs, error number API or the error message API. So this one is the numeric number. This pointer is based on numeric number, and this is based on the character. Now I define two constants, CR and LF, which basically denotes that the end of line, and LF denotes the new line started after this. And this is text line, so which I'm going to retrieve from the IFS read. And this is the position and length variables which I took just to read the data one by one, because I'm going to read every single byte and will check whether it's a CR or an LF. So let's see how I perform that. So first thing is I have the IFS path. So if I want or if you want, you can ask user input to this program, that is the IFS path. So I hard coded it here, slash home slash easy class slash text file 1.txt. This file is already present on the IFS. Let's see. So this was the file which I created using the create or write text file video. So you can check this there on the creating or writing the text files on the IFS video. You'll get this information that how I written this as a text file, because you can see these are in the separate lines, and uh, they are CR or LF character inserted between these. That's why they are showing in the separate lines. So let's see the program. So I'm opening the file in read only mode, so that's why I don't need mode parameter, that is the authorities parameter here, because I'm not creating that file. So I'll pass these two flags because those are optional. So I'll be getting a file descriptor. If it's less than 0 means there's some issue in uh, opening the file. So in that case I'll call the error number API and receive the pointer, and we'll pass that error number to the strerr API, and we'll receive the error message pointer, that is the error message, and will return from here, because I'm not going to perform anything because I'm not able to open that file on the IFS. So if it is opened, we'll come here. What we do, we read the IFS file. So we'll pass the file descriptor which is returned from this uh, API, open API. The file descriptor is unique to all the files. So if I open two files, that the file descriptor would be 0 or 1, 0 for the first file or 1 for the second file. Or in case if I already opened multiple files in this session, so I'll be getting the file descriptor after that, because that's unique to the field to every file. So let's pass the address of the IFS data, which is 10 characters. So on this IFS data we'll receive 10 bytes or 10 byte text from the IFS file, and this is the size of the IFS data, and we'll receive the return read. So actual number of bytes returned from the read API will be here. So I just set the position to 1 and will ask for running a loop that is from position 1 till less than equals to return underscore read, because it could be possible that I would get some less number of data. If I would take IFS data size here, that's wrong, because IFS data size is 10, but let's say there are only 8 characters, so I would be reading or I would be running the loop until that 8 characters are read. So I'll be keeping this condition, and within that condition, so the first thing is on every byte I'll check CR or LF. So if it's a CR, it means that's the end of the line. Okay, so I'm checking if person substring IFS data position, that is position is currently 1, the first position 1 till 1, length is 1. So on the first position, if it's CR, then clear the text line. Even I can ask for writing the text line or passing the text line to some other program, or writing to it to the some, let's say, file or somewhere where I want that lines to be provided. I can pass them. Here I don't need to do those things. I'm just giving you the demo that how we'll be extracting the lines. So I'm clearing the text line, so it means there's nothing. If in case it's not CR, or I'm also resetting the length here, you can see the length would be currently it's 0, so if it would be on the first line, it would again be 0. Else otherwise, if it's not CR, what we will doing, we are substring the IFS data position 1 till 1 length. If we are checking it's not LF, means if it's LF, it means after that we are actually getting the new line. So if it's LF, we are not going to write that into the, or we are not going to extract that position into the text line from that length. So length would be, let's say if it's not LF, so length would be currently 1, and 1 till 1 will write the IFS data position 1. So its position would be, let's say, first. So first from the first position of IFS data, will write to the text line of the first length, first position. So we will do this in loop, and then we'll check if position equals to return underscore read. So let's say return underscore read is 10 or 8 something, and position is becomes same, that is the loop runs that number of times. And then what we'll do, we'll reset the position and we'll again call the return we'll again call the read API, and we'll get the return underscore read. And otherwise what we do, we increase the position by 1 every time, and this loop will run until the return underscore read is not equal to, is not less than equals to return underscore position is not less than equals to return underscore read. So here also you can see I'm again calling once I'm reading all the return underscore read positions or the bytes, then again calling the return underscore read API to get next 10 bytes, and performing the same thing on the data. And at last, once all the lines are extracted from the IFS file, we'll be calling the close API and passing the file descriptor, and we'll getting the return underscore close, that is closing the API file. If it's less than 0 means -1, there is some error, we'll again call the error number or error message API to return the message and return from the program. that's it. So let's compile this. Take 40 Shannon. It was already compiled, but let's compile it again. Just do debug. Let's set the breakpoint and then call read text. Just take F10 here. So this is the IFS path and this is the flag value, that is for read only one, and we'll pass this to the open API and we'll receive the file descriptor as 0, which was, so if it's not less than 0 means no error, the file is open. Now we will pass this file descriptor to the read API and pass the address of this IFS data where we will be receiving the data of this number of bytes, that is the 10 characters. So I would actually getting 10, so there are 10 more than 10, so I'm getting more than 10 or 10, so I'm getting return underscore read as 10, that is I read 10 actual bytes. Position is set to 1, 1 is less than equals to 10, so it will run 10 times. If IFS data position, so on first position, if it's CR or LF, we cannot see any CR or LF here, these are the correct data. So what I'm doing, I'm not going to execute these lines, I'm always executing else part, and if it's not LF, we'll be writing to the text line. Text line contain I now. Position is not equals to return underscore read because it's 1 right now, so I'm increasing the position. So let's say just put the breakpoint here, just take F12, position is 2, take F12, position is 3, just check if it's populated. So it is populating from this IFS data after checking CR or LF. Let's see 6, so it's 8, it's 9, and then it's becomes 10. So I'm again will go to inside the loop because the condition is true, and then we'll see if it's LF, it's not LF, and we'll write this as well. So we'll get all the data IFS text space F or whatever there in the IFS data. Now we are seeing that is the position is equals to 10 equals to read underscore read 10. We read all the 10 bytes returned from the read API. So we'll reset the position now because we are again going to read the text from the first position. Position is set to 0, and then we'll again call the read API to return the actual bytes being read. So bytes are read and now we have some data. So you can see ILE1, then question mark IFS. So this is basically CR and LF, which denotes the end of line and the next started line basically. So position is set to 1. So what I'm doing on first position we don't have that CR or LF, so we'll write this to the text line. So you can see text line was not cleared because we didn't receive CR yet, and we are actually accumulating after this, which is actually correct because that's a single line. Again I got this. Let's see what we receive. File Now the position becomes 4. We have some data, that is 1 here, which is again going to be here, file 1, IFS text file 1, position is 5. On the 5th position we have CR character. Let's see. So percentile substring IFS data 5th position 1, 5th position CR is there. So the constant is defined here. You can see the hex value 0D or 25 for the LF, line feet or the characters, which denotes uh, the end of line or the new line thing. Now we won't going to the else part here because we received the CR and we are not going to write anything. Now we actually cleared the text line because we have received the first uh, line here. So what we can do here, after before clearing, we can even write that data to some file, so we can pass the data to something else, or we can store that somewhere on in our program itself, so that we have the knowledge of what the lines were. So this was the demo. So you saw how I extracted the line. Let's extract the second line as well. So now this time you'll see we are here on the 5th position. Okay, so that's not correct, so we'll increase the position to 6, and this is something we are receiving the on 6th position we have LF. So we are not going inside this to write uh, the the data to the text line, which is blank right now, and the length was reset as well. Now again we'll move it to 7. On 7th we have IFS and blank. Let's put the breakpoint here, just to F12, F12, 9, and it's 10. So we receive that value IFS here, IFS and blank here. So return underscore read will read next 10 bytes, and we receive text file 2. Position is 1 again, and now IFS data position 1 will receive length to the 5 because we read 4 characters previously, and this will see IFS test, just to so we receive all the data IFS text file 2, and we reset the position now again because it was 10 earlier, and we read next 10 bytes. So now in the next 10 bytes we'll see CRLF something like this, because we have blank in between that, we are nothing having in between this and end, and then CRLF like this. Let's see. CR is encountered, so text line is clear now. So that was the second line, and then position was incremented to 1, that is 2. Now LF was encountered, so we will not write to the text line, and then again we'll clear the position. It means that was blank line, and now we'll again clear the position. On 3rd position we get CR, and then on 4th position we'll be receiving LF. So we're not going to write that, you can see. Now on 5th position we have end, so we will be getting that as a new line, EN and D. So we'll receive the CR and we have cleared the line. You can see that means that's the only word there in that line. and now we'll receive the LF. So we won't write anything. We have that blank, so we'll write the blank here, which means we are receiving the blank data. Now we need another 10 bytes, so here we have blank. So now we have a blank data in the file, which is not going to be anything important for us. So we'll keep the breakpoint here, and we'll see at what time, after what instances we will receive return underscore read. So let's say, just don't do this, just keep a watch on return underscore read when the end of file is reached. Basically just take F12. So here, after executing this line, we receive return underscore read as 0, which means there is nothing after that. So position is set to 1. So position is set to 1, which is less than equals to return underscore read. So return underscore read is 0 this time. So I will be coming out of loop, means I have read all the data, I have extracted all the lines, text lines basically, uh, from the IFS file using the read API, using this program, and then I'm going to pass the file descriptor to the close API to close this file. So if it's less than 0, means some error in closing the file. So the file is closed, which you can see here. We won't get there to the error section, and this is the end of program. Just to end debug. So that's all here. So you learn about how you can read a text file on the IFS in AS400. So that's all. Thank you and have a nice time.